Welcome to part 2. In the previous video I showed a couple of methods for creating these less simple surfaces and a tool to help you check the continuity and quality of those surfaces. In part 2 I'll be using the same methods to create a more complicated surface, again seeing the weaknesses to the methods if the modeling process isn't planned properly. So I start with drawing out the top profile and include a straight edge at an angle towards the ignition barrel mounting. I then extrude that surface up, ready to trim away the top of the quilt. Now I want to connect this straight edge exactly to the edge of this ignition barrel mounting. So to make that easier, I'm actually going to cut away part of the ignition barrel mounting so that I can get a hard point on the circumference. Now that I have that hard point on the circumference, I'm going to use the plane on 3 points feature. I'm then going to sketch the surface that's going to be connecting this edge to the ignition barrel mounting. Now because the straight edge is at an angle on the surface that it's been drawn on, and that surface is at an angle relative to the ground plane, we're going to get a kind of twisted or angled surface that's going to be formed here. Then we can trim away the unwanted material. Now we can start looking at creating the vertical surface to join this top surface to the more complex, interesting surface feature. I'm going to do this using two sketch features. The first one is going to be a sketch on the profile, and then once that sketch is finished, we create a new sketch and then reference that sketch to be projected to the surfaces, and then we'll change it to by vertex, selecting the z-axis. Once that's done, we can start extruding the surface down just a few millimeters, and we can add taper if we want to. I'm going to start building the more complex surface. So I'm going to do this with two surfaces really. The first one is going to be a revolve around the axis of the steering stem. So I'm just going to use a straight line in this revolve, and I'm just going to adjust the position roughly to where I want it to be. Then we can trim away the right hand side, since we'll be mirroring this part, as well as the lower part because we won't be using that. Now in order to connect the lower surface to the top surface, I'm going to need to join those surfaces with another surface feature. And in this case I'm trimming away the left side of this quilt using this sketch. This sketch is going to be the angle at which the surface is going to be swept. So if you want to adjust that surface, I'll have to go back and adjust this sketch. So in order to create the sweep feature, I need to create a plane on the end of this curve, draw a sketch, constrain it at a length and an angle. We're about to see the problem with using this feature as freely as I'm using it now. Since there are a couple of lines defining the geometry of this surface, it's a bit more difficult to get it exactly how you want. In this case we have the line that's creating the line which acts as the path for the sweep, and then we have the sweeped curve as well. Not only that, but the surface that is being used to sweep along is also at an angle in its revolve feature. So now we see we are extending above part of the surface we want it to join into. Now we could go into the sketch and modify the dimensions to try and improve this, which I will show in just a moment. but we'll see that the result is not ideal since there are so many other features that influence this design. So now looking at one of the other methods, we can create a plane on 3 points and then create a sketch to patch. Now it's just all the housekeeping, trimming away the excess material and stitching together the quilts. We may have to extend some surfaces to make that possible, but in some cases this material is going to be trimmed away, so it's not really going to be a problem. So at this point I can start looking at bringing in the ignition barrel surfaces and stitching them into the main quilt. So I just have to recreate this cylinder because I've already trimmed away half of it, and I actually need that now to cut away some of these surfaces. So from now it's just going to be tidying up, trying to trim down the surfaces and stitch them together to a single quilt. So there are still some surfaces that we need to build around the profile of the part, and that's starting from here. I'm going to trim this part by the line here and then create a patch between this edge that we've just drawn and the edge for the ignition barrel. Again, using the plane with 3 points and then the patch feature. Lastly, there's the inner surface of the ignition barrel mounting. Here there's different levels that we want to trim it to, so we just need to extend these surfaces to make sure everything can be trimmed cleanly. Okay, so now ready to stitch this into the main body and then finish trimming off the other intersecting edges. So now all the surfaces are complete, we can finish trimming and stitching that all together, and then we can mirror that across to have one final top surface. So from here I need to add the ignition barrel mounting features on the underside, and then I will start looking at the aesthetic features or the rounds and chamfers. You can also test out the zebra analysis tool on the whole part just to see how the surfaces are looking. Okay, so using simple modeling, I added some final features and some cuts to the piece. I've then come into the render mode and then added some material appearances to the part. So I think this is going to be my last video modeling top yokes, unless there's any requests in the comments. I think the next thing I'll try to do with this would be to 3D print it and then potentially paint it to try and make it look as real as possible. Thank you again for staying to the end, and I hope you've taken away something that will help you with your modeling in the future.